Measures of position gives a range where a certain percentage of data falls. So in measures of position we have percentile. Percentile is a measurement such that after the data are ordered from smallest to largest, at most p% of the data are at or below this value, and at most 100 minus p% of the data are at or above it. So let's say we have our axis showing minimum and maximum points. Now here we can see that p% of the data falls below it and 100 minus p% of the data falls above it. So this is what percentile means. After that we have 5-point summary, which is minimum, maximum and 3 quartiles. Quartile 1 is 25th percentile, which means 25% of the data is below it and 75% is above it. Then we have quartile 2, which means 50th percentile. It is also called median. So 50% of the data is on the left hand side and 50% of the data is on the right hand side. And then we have the quartile 3. It means 75% of the data is on the left hand side and 25% of the data is on the right hand side. We also have quartile 4, which includes 100% of the data. So these were the measures of position. After this we have measures of dispersion. Measures of dispersion are also called measures of variation. So in this we will only see the commonly used terms. The first term is standard deviation. Standard deviation basically tells us how far a data point is from the mean. The lesser the standard deviation is, the closer the points are from the mean. The formula for standard deviation is shown here. Here x is an observation, mu is the mean, n is equal to number of observations, and if we are talking about sample, then we will use n minus 1 instead of n. After this we have variance. Variance is the square of standard deviation. Then we have coefficient of variance. It helps us find the relative variance in the data. It is given as standard deviation divided by mean. Let's look at one example to understand this. Suppose we have two datasets. Dataset 1 has standard deviation of 12 and mean of 80. Dataset 2 has standard deviation of 0.2 and mean of 0.5. Now by looking at these figures, can you conclude which standard deviation is better? Is 12 better than 0.2 or vice versa? Well, the answer is no. So to address this problem, we use coefficient of variation. We use the above formula and find CV1 for sample 1 and CV2 for sample 2 as 15% and 4% respectively. Now the advantage of CV is that we can compare it in absolute term. Hence we can tell that 4% variability is better than 15%, and we can conclude that sample 2 is better than sample 1. After this we have range. Range is nothing but a difference between two extreme observations, and it is given by the formula xmax minus xmin. Lastly we have interquartile deviation, which is given by this formula 1 by 2 into Q3 quartile 3 minus Q1 quartile 1. Now Q3 minus Q1 is also called an interquartile range. So these were the measures of dispersion.